Okay, guys, I sort of got cut off in my video part one. So let's go back and make sure you understand. Guys, we're graphing quadratics instead of in vertex form. Sometimes they're given to us, quadratic equations are given to us in standard form, where we can't just right away see the vertex. So what we've found is that if we take this number in front of x and take the opposite of it, and divide it by 2 times the number in front of x squared, we get the x coordinate of the vertex. And then if we just put that x coordinate back in for x, we get the y coordinate of the vertex. See, the vertex here we can see is 2, 3. Here we couldn't see it, but we can find it. Okay, so I know we did a couple of these already, but I just want to show you the work. Okay, here I can see that the vertex is -3, -5. Love it. This is the same equation, just given in a different form. We're going to take the opposite of b is 12, divide it by 2 times a, which is 4. -12 divided by 4 is -3. Yep, that's the x coordinate of the vertex. Then we're going to put -3 in for x in this equation. 2 times -3 squared plus 12 times -3 plus 13. Do that in my calculator. I get -5. Here I can see that the vertex is 4, 0. This is the same equation, the same graph, or the same parabola written in standard form. I'm going to take the opposite of b, so that would be +4, divided by 2 times a half. 2 times a half is 1. 4 divided by 1 is 4. Yep, that's the x coordinate of the vertex. If I put 4 in for x, 4 squared is 16, half of 16 is 8, minus 16 plus 8, yep, I get 0. Here I can see clearly that the vertex is 0, 10, okay, because it's in vertex form. Oh, standard form and vertex form are basically the same here, aren't they? Ooh, isn't that interesting? Okay, I can think of this as x minus 0 squared plus 10. Or x plus 0 squared. I would write x minus 0 squared plus 10. And I can see the vertex is 0, 10. So if I don't notice that here, I notice that b is 0. Well, I'm going to take 0 over whatever. Doesn't matter what I divide 0 by. 0 divided by anything is just 0. I put 0 in for x, and I get 10. Okay? So then the axis of symmetry, of course, is going to be x equals the x coordinate of the vertex, just like it was in vertex form. Okay? And so that's what we do. We look at the x coordinate of the vertex. Like, for example, the axis of symmetry for this one would be x equals 0. The axis of symmetry for this one would be x equals 4. Okay, to find the y coordinate, we substitute x back in. Okay, so if you want to pause that or jot anything down from there, those are the key points. The differences between graphing in standard form and in vertex form. Okay, so a little more organized for us. The axis of symmetry, of course, is x equals the x coordinate of the vertex, and the x coordinate of the vertex we found is the opposite of b over twice a. The vertex has the x coordinate of the opposite b over twice a. You substitute that back in to find a. The parabola opens up just like in vertex form when a is bigger than 0. It opens down when a is less than 0. The y value of the vertex is a minimum when the parabola opens up, right? In other words, when the parabola is opening up like this, then that vertex is going to be a minimum value. When the parabola opens down like this, then the vertex is the highest that parabola will go. It's a maximum. So y-intercept, we noticed y-intercept means I put 0 in for x. The y-intercept is always 0, c, whatever c happens to be. And just like in the vertex form, the parabola is narrower than our parent graph if the absolute value is bigger absolute value of A is bigger than 1. If A is 2 or 3 or negative 4, the absolute value of negative 4 is positive 4. So that would make it more narrow than what y equals x squared looks like. If the absolute value of A is less than 1, like a half, 3/4, negative 2/3, then it's going to be wider. Okay, and then we take whatever A is, even if it's a fraction, and we take that over 1, we can find the next point. We can find 2 points on either side of the vertex that are 1 unit to the right and left, just like we did before. Okay, so let's try that. We're going to graph this function, graph this quadratic. It's given to us in standard form. A equals 2, B equals -8, C equals 6. I know the y-intercept is 0, 6. I might even graph that. Wow. 1, 2, 3, 4, 5, 6. Okay. Does it open up or down? Well, 2 is positive, so it opens up. Axis of symmetry, it's x equals something, whatever the x coordinate of the vertex is. Okay. So I need to find that. I'm going to take the opposite of B over twice A. The opposite of -8 is 8 over twice A. 2 times 2 is 4. 8 over 4 is 2. So the axis of symmetry is x equals 2. And my vertex is at 2. I don't know. 2 something. To find it, I'll put 2 in for x. The y coordinate equals 2 times 2 squared minus 8 times 2 plus 6. I'll do that in my calculator or in my head. 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. So it looks like it's 8 minus 16, which is -8, plus 6 is -2. So my vertex is 2, -2. So now I know this is my axis of symmetry. This line's cutting my parabola right in half. So I can reflect this y-intercept over the axis. 2 units away from this symmetry is another point. So I could graph it from here. However, we oftentimes use A to find points 1 unit to the right and left. A is 2. So from my vertex, I'm going to go up 2 over 1 and up 2 over 1. So it looks like my 2 points are 1, 0 and 3, 0. And then I'll graph that. Okay, so you can see the parallels, the similarities of what we did before. Let's see, the vertex is, looks like a smiley face, doesn't it? My vertex is a minimum because I was opening up. Okay, if they ask me for the range, I would say y is going to be bigger than or equal to -2 all the time. Every y coordinate is going to be bigger than or equal to -2. That's how you graph in vertex form. Okay, so let's try this one. Axis of symmetry and vertex. I don't know until I take the opposite of B over twice A. The opposite of, okay, so what's this? I guess I should write down A is 1, the number in front of x squared. B is -4. C is 2. As soon as I see C is 2, I know that's my y-intercept anyway. The axis of symmetry, I'm going to take the opposite of B. What was B? -4. So the opposite of that's +4. 2 times 1 is 2. Oh gosh, I have 2 again. Oh well. Axis of symmetry is x equals 2. The vertex is 2 something. I don't know. It's 2 comma something. I have to put 2 in for x. 2 squared minus 4 times 2 plus 2. 4 minus 8 plus 2. -4 plus 2, I get -2 again. Oh well. So the vertex is at 2, -2 again. Okay. The y-intercept is, I already said, 0, 2. Okay. And let's find some more coordinates. Let's see. A is 1. So I'm just going to go up 1 over 1, up 1 over 1. Okay. So the points 1, -1, the points 3, -1. I can, translate this 2 over here to 4, 2. Okay. Another point, I don't know. I guess I'll just stick 5 in and see what I get. 5 squared minus 4 times 5 plus 2. 25 minus 20 plus 2. 5 plus 2 is 7. So when I put 5 in, I got 7. I don't like, when I'm going to find more points, I kind of like to rotate it across the axis of symmetry. So there's another 7 over here, 3 away from the axis of symmetry. Okay. So there we go. Let's see what 4 points they got. They got 3, -1, 1, -1, 4, 2. Oh, the same ones we got. 5, 7, and -1, 7. That's 5 points. 1, 2, 3, 4, 5. Okay. You can pause me, look at that a little bit if you'd like. Okay. Just trying to see. Okay. Let me see how much time was left. All righty. Now, interestingly enough, like we said, when it's ax squared plus c, we realize that b is 0. That means really our axis of symmetry and our vertex is at 0 something, This one's going to open down because that's negative. The axis of symmetry is at x equals 0. Okay, and so our 0, 3 ends up 0, 3 ends up being our vertex as well as our y-intercept. Okay, that's just the only difference there. Everything else is the same. The vertex and the y-intercept are the same. Okay, which is interesting. We can still use a, -1/2. So I'm going to go down 1/2 over 1. Down 1/2 over 1. Notice the y-axis is on by 1/2. Okay, just to give us those other points. And we just can't maybe find as many. This is going to be a maximum point. Really, to draw a parabola, you need the vertex and a couple points, right? So we found those 2 points because A was -1/2. All right. The vertex is a max because it's opening down. Okay. So let's try this one. The axis of symmetry, again, is going to be x equals 0 because B is 0. The vertex is 0, 3. Okay. My y-intercept is also 0, 3. That's what happens when B is 0. And now to find the rest of the points, it's a little tough because we have this 1/3, right? But I'm going to go 1/3 of the way down and over 1. 1/3 of the way down and over 1. So that means this point is 1, 2, and 2/3, right? I went 1/3 of the way down and over 1. This is -1, 2, and 2/3. Okay, and to find other points, I think I'm going to put 3 in. 3 squared is 9. 1/3 of 9 is 3. 3 plus 3 is 6. So 3, 6. I'm sorry, I messed up. I don't know why I went down. I was yesterday, or the last one was negative. This is a positive 1/3. I should have gone up 1/3 and over 1. Up 1/3 and over 1. Thanks for catching me, guys. Sorry about that. Okay, so it's actually 1, 3 1/3. -1, 3 1/3. And then I can go 3 in the other direction. We knew this was going to be wide. Okay, so our other points, let's make sure they got the same ones. Yep. That's 3 1/3, 3, 6, -3, 6. Sorry about that. I rushed through that. Okay. Here's our little mouse. You can look at that, pause it. I'm going to put the answers. We'll go over that in class. See you in class.